Hey everyone, this is Ben Ward here, and today I wanted to show you how to create this interpolating wavetable oscillator patch. So the way this is going to work is it'll allow you to define the two waveforms that you want to interpolate between by drawing them in, just like this. And then using the slider, it'll interpolate between those to create a new waveform. So I'll show you kind of how that sounds. You can see here, we have the full right side of the waveform, and if we go all the way to the left, now we're copying this left side waveform. So that's going to be the goal. As you can see, we also have a frequency dial here, but that's what we're going to be doing. So to get started with this, I'm going to introduce a couple of objects that are going to be really useful for wavetable synthesis. The first of which is going to be called buffer tilde, and this is a really useful object in Max. What it allows you to do is define a table of data that is going to be accessed for audio rate purposes. So unlike other data table objects in Max, this one can be accessed by other objects and be played back at audio rate. However, you do need to give it a name, that way you can reference it with those other objects. So I'm going to call this one wave1. And now what we're going to use to access that is an object called waveform tilde. And this will essentially display and allow us to edit the contents with the buffer that we specify. So to specify that buffer, you can type @buffer name, and then we'll say wave1, and that'll create that. And so right now this is displaying the contents of this buffer. However, this has no data within it, so we're going to want to change that. And now the next thing you're going to want to do is specify the size of your buffer. Now you usually want this to be a power of 2. For wavetable synthesis, I recommend at least 256, but you could do 256, 512, 1024. Anything past that is probably a bit unnecessary. So for this example, I'm going to stick with 256. And then if we type that in the message there and send that out, there we go. You can see that's instantiated that, and now we have a bit of data to work with. So the next thing I'm going to do is change the mode of this, because while this allows you to view the contents of the buffer, we're actually going to want to use this to change the contents of the buffer. And we can change that by sending the message mode draw. And you could also change that in the inspector if you want, but I think it's faster just to do this. So now if you do that and command click, now you can actually draw the contents in this buffer. And there is another way to view the contents of your buffer. If you command click on the buffer object itself, that will pull up a little window so you can see what it's actually storing. And now you can see we just drew this waveform in here and it matches it just like that. So that's all working well. And now the next step for creating a wavetable oscillator is actually playing back the waveform that we've just drawn in. And there's a perfect object we can use for this, which is called wave tilde. And just like the waveform object over here, we need to specify the buffer that we're going to read from. So I'll type in wave1, and perfect. Now the inlets for this, really the only one we want to focus on is this left side inlet, and that is where we're going to send our phasor object. Because the way this is going to work is this needs a signal in order to read the contents of this. And because we just want to read it exactly as we've specified here, we're going to want a ramp signal for that. So if we plug this phasor into the waveform object, then we can get a frequency dial. I'll do live.dial, go over to prototypes, and click frequency. Now we have a frequency dial. I'll plug that into the phasor, and now this is going to send the frequency that we want to the phasor, and that's essentially going to create a sawtooth ramp at the frequency we've specified. Then using that signal, wave tilde is going to take the signal from the phasor and use that to read through the buffer content. So Now that we've done that, I'm just going to grab a live.gain. We can see the signal there, and then finally an easy DAC, so we can, easy DAC. There we go, you should be able to hear that. We turn that down, frequency dial is working, and let's just test that these changes are actually changing the timbre. Perfect. Cool, so we've just finished making a simple wavetable oscillator. This is a good structure to remember if you're ever going to be doing more wavetable synthesis. But now the next thing we're going to want to do is add a couple more buffers, and then we're going to need to interpolate between those two. So in total, we're actually going to need 3 buffer objects. I'm going to call the second one wave2, and I'm going to call the third one interp. And this is the buffer that's going to store the result of the interpolated waveform between the wave1 and wave2 buffers. And first thing we should do is just specify the size of these buffers. We're going to want all of these to be the same. You notice that once I did that, that changed or cleared the first buffer that we drew in, so I'm just going to fix that. But now, cool. And since we had those buffers, I'm also going to make some waveform tilde objects so we can view what's going on in those. So I'll do at buffer name wave2. And waveform at buffer name interp. So now we can view those, and then I'm just going to send this draw message again to the second waveform object. I'm not going to send it to the third one because we actually don't want to edit this one by hand. We're just going to use this to display the interpolated results from the 2 waveform objects that we are drawing in. So we're going to do that. Let's just draw some stuff in here. Cool. So now if we take a look at our original example, the next thing we should incorporate is this slider here, because this is what we're going to want to base all of the interpolating algebra off of. So I'm going to go ahead and make a slider just like that, and then I'm going to make it horizontal because that's going to match how it's going to look in the end. If we start thinking about how we're going to interpolate, the first thing we need to think about is how we're going to actually access the data in our buffer objects. And the way we can do that is with an object called peak tilde. And just like wave and waveform objects, we're going to want to specify the buffer we want to read from. So I'm going to type in wave1. And then I'm going to type peak tilde wave2. And one important thing to note is some of these objects require a buffer name as an argument, and then some of them, like the waveform tilde object, this one doesn't require it right here. Instead, you need to type it in as an attribute, buffer name, and then the name of your buffer. So just a little distinction that's important to note for that. But because peak requires a buffer object to work, it's a necessary argument. Whereas waveform, you could do some other things with it if you want to. But anyways, so here we have the peak objects, and this is what's going to read the data from the buffer object when you input a sample index into the far left inlet. So if I show you that, you can see as I increase this, we're getting different values from that, and that's because it's reading the data from this using the sample index, which is going to be anywhere between 0 and 256, which is what we specified for the size of the buffers. But in order to get the interpolation algorithm working, I'm not going to work with these peak objects, and instead I'm just going to use a couple of float values. The reason is because if we get it to work with these 2 values, then it'll be really easy to just plug in the peak objects to replace these incoming values. So I'm just going to go ahead and specify a couple points for this. Remember, all our values in the buffers are going to be between -1 and 0. So I'm just going to use these as an example. And now what we're going to want to do is first think about how this slider object is going to work. So if we remember at the far left, we're going to get an unchanged version of the left waveform, and on the far right, it's going to be an unchanged version of the right waveform. So if we do that, then we can think about scaling these objects based off the position of the slider. So since this one's going to be at the far left, it's going to output a value of 0. Oh, sorry, it does do that, but we're going to want this in the range of 0 to 1 and be a float slider. So if you go into the inspector for the slider, you can click on float output and then change the range to 1, and that'll give us the range we need. Perfect. So when this is at the far left, it's going to send out a value of 0, and we can use that value actually to multiply it by the value we don't want at the far left. So we're not going to want the right value, so we could take that, do multiply 1 dot, because we want a float value, plug this into the right inlet and this into the left, and so we'll get 0 for that. However, we want to multiply this value by 1, so we're going to want to invert what the slider is doing for the second incoming value. And you might think we could do that with a simple subtract object. However, the inlets are different for this, because if you see when we plug this in, we're actually getting -1 for this value. And instead we want +1 because we want to multiply it by this left incoming value. So the way we can fix that, well, you could just multiply by -1, and that would serve your purposes. However, there's a better way to do this in Max, and it involves doing this. So for the subtract object and the divide by object, it actually allows you to flip the operators of those, because there is no way to do 1 minus this value while you have an incoming value. You can only subtract 1 from that value, and that's why we got the -1. But if we do this, however, now we're doing 1 subtract the value coming in here. So let's just make sure that looks right. Perfect. So now at the far left, we get 1 on this side, 0 on this side, and if we go all the way to the right, perfect. Those have been reversed. So then all we need to do is get another multiply object, type in 1 dot. We will plug this into the left inlet, put our scaled value into the right inlet, and let's just see how that looks. So here we get 1. Oh, let's bang that. So we have those values in again. Cool. So at the far left we have 0.4, and at the far right we have -3.6. However, it's still not going to work with any of the values in between. We got it to work how we want for the far left and right values, but these in-between values isn't quite what we're going to want to get. Because it's interpolating, we need to combine these values, and there's a really simple way to do that, which is just adding. So if I do +1 dot, plug that into there and that into there. Oh, not from the message, but from here. And let's see how that works. I'll move this down a bit so we can see. So now at the far left, we still get 0.4, but then as we go to the right, it's slowly approaching this -0.36 value. And once we get to the far right, there it is. So that's pretty much it as far as the interpolation algorithm. It's working exactly as we intended, but now we just need to change it so that we have these peak objects coming in to the left and right inlets. So let me just clean this up a bit. And then I'm going to grab these peak objects, move them down here. We don't need this anymore. And if I replace these with the peak objects, that should be just about it for that. Now we need to think of a way to get all the values from this peak object virtually at once, because we want this to work as a continuous effect. The thing is with the peak object is when you send it a value like this, it's only going to output that single value. However, we want this to update even if you make a change really quickly like this onto the waveform. So the way we're going to do that is with the Uzi object. And what this does is it sends out a number of bangs dependent on the argument you specify here. So since we know that our buffers are 256 in size, then we can type in 256 for the Uzi. And then whenever you send this a bang, it is going to print off, here, let me grab the print object. It'll print off 256 bangs. Probably can't see this very well, but now I have a bunch of those in my console. However, we don't want the bangs themselves, but rather an index for that number of bang. So we can actually get that from the right index. So if I plug these into the peak objects, every time I click this, it's going to send out 256 values between 0 and 255 into the peak object, reading and sending out all of those values, and then interpolating them. So let me just print that to make sure it works. I click on that. Let me see. It doesn't. What are we doing wrong? Oh, it's because I need to update it with the slider. So when we click the Uzi, it does send these values out, but because it's going into the cold inlets, it doesn't actually update to the print object until we change the slider. Now the last step is going to be sending the outputted values or the interpolated values into our final buffer, which remember we've called interp. And we can actually do that using the peak object again. So not only does the peak object allow you to read data from a buffer, but you can also write to a buffer using the sample index and a value. So right here, we specify the sample index. Here we specify the value we want to write in. So since we're already getting the sample index from this Uzi object, we can simply take that, plug it into the sample index here, and then if we take this, plug the output of that into the value that we want to write to the buffer, that should just about be what we need. So let's see, I'm going to grab this because we should be able to see the changes in this resulting waveform object. Let me make that a little smaller. Cool, and if I change that, nothing. Let's try Uzi. The reason is because, okay, we need to trigger this Uzi object every time that the slider makes a change. And so I'm going to grab a trigger object for that. And this allows you to specify an order for different messages based off an input. So we're going to need a bang and a float from that. Put that in between there. So our float values are going to need to go to these two objects because those need the value to calculate. And then the bang is going to go to the Uzi object. And now when we change this, it's not only going to send out the value from the slider out there, but also send a bang to the Uzi object so it can update the values and send it into the peak interp object. So let's change that. And still nothing. Okay, I see what I did. So the reason this isn't working is because every time we click this, the first thing that's happening is it's sending the float into this hot inlet and then into the hot inlet. So it's only sending one value, it's only triggering one calculation for this. And that's why when I change this, you can actually see we are changing the buffer, but it's only this first value. So what we need to do is switch the order of the inlets into these multiply objects. So I'm going to grab the peak one. That's going to go in there. Put that into the cold. Switch these. Now if you see, whenever we change the slider value, first it's going to send the slider value and update the new interpolation ratio that we need for those, and then it's going to send all 256 values from the peak object and calculate it based off that. So now if I change this, there we go. Now you can see that this is changing and updating. If I go to the far right, it should look like this one up here. And it almost does. Let's see, I'm going to move this just so we can test it. Is that working? Almost. It looks like it's extended. Oh, okay. Alright, yeah, so it is working. I was just cutting it off a little bit there. Perfect. Yep, so that one matches that one, and in the far left, that matches the top one. So that's just about it. The interpolation's working. We're reading the values into the buffer. It is a little messy right now, so I could clean that up for a bit. But in order to hear this now, all we need to do is, since we've already created this first wavetable oscillator, we can just change the name of the buffer we want to read from. So that's going to be interp. And now if I turn this up, we can hear it. It's going at 81.5 hertz for the frequency. And now if I start changing the slider, let's just hear the changes of that to make sure that's working. Perfect. And you can hear it get smoother when we have this smoother waveform, and it's a bit harsher when we go to this left one. So that's pretty much it as far as the functionality we want to add for this. I guess the last thing we could add is a scope object. And that's going to read a signal from this, and that'll just give us a new way to view the incoming value from our waveform. So we can see it like that. I'm going to go into the inspector, turn on automatic mode. That's really useful so you don't have to play with the settings yourself. And let's see, if we start changing this like that, we should be able to get a pretty clear view of that on the waveform or the scope object. Yeah. So it's having a hard time finding the right values for this, but you can kind of see that it's matching some of the spikes in this. A little different because it's scaled quite differently, but we can fix that in the presentation mode. And actually, I'm going to go ahead and get started and do that. If you remember, our initial example looked like this. So I'm going to try and make a similar thing for this. So let's see, we're going to want this object, this object, this object. Oops. Okay, grab the frequency dial, gain. I'm holding shift to click all of these at once. This object there. Need the slider. May as well grab the easy deck. Okay, and that should be it. Then I'll hit Command Shift P. That'll add that to presentation. There we go. For backdrop, I'm going to get a panel. Just change the interior to be not gradient because I don't really like the gradient. Just do color fill and black. I will give it a border. Cool. And then I'm going to zoom out a bit so you can see everything here. Also important is to include it in the background so everything lies on top of that. Do this. Let's see. Here's our first buffer. Here's our second. Interpolated. The scope view for that. Make that a bit smaller. Frequency dial. These I'm going to want to change the text to white so I can see it. I'll just do that. Turn this up, make sure we can hear it. Oh, my slider, I forgot about that. Put that in the middle. So now if I go left, it's making this waveform. If I go right, we get that one. Should be able to change these. Cool. And then I'm just going to add a title to this, because why not? And the way I do this is just with a comment. I'm just going to type waveform or interpolating wavetable. Put that in the center. Change the text color, white. Font, if you want to do that. Font size. And cool. So we can change the frequency. It's just like any other typical synth or oscillator. But now we can define the waveforms by hand and then even interpolate between them. So yeah, that's pretty much it. I hope you found this video helpful. If you did, please leave a like. And if you have any ideas for other topics I should cover in Max, please let me know and I'll do my best to try and look at those when I can. So yeah, thank you.